on these quiz problems. All right, so the first one, let's go. I just want to go through a couple things really quickly with this first, which is this a proportion or is it a mean?
Is it a proportion?
Well,
I think.
So do you see the word mean anywhere in here? Do you guys see the word mean?
Yeah.
You see the word mean right here?
Oh, yeah.
So it's a mean. This is a mean.
Mean, yes.
So this is a mean, which means you're going to be using a t-table, right, because of mean Mr. T, which means you also need to find degrees of freedom, right, n minus 1. Let's figure out the things that are important here. So the claim, so right away we have a claim. This is my claim. The claim is the mean is less than 124, so that's your claim right there. And then you have a sample. So it says sample, so this is your sample. Sample of 19, that's your n, has a mean, that's your x bar, your sample mean of 120, with a standard deviation of 6, that's your s. So those are kind of the pieces that you need. And then you have a significance level of 0.01, that's your alpha. Okay. So kind of make sure you guys get used to this idea of finding all these pieces in here, because it's a lot of numbers, and some numbers matter and some numbers don't, and you need to figure out which ones are which. So since this is my claim, then 124 is my mu. That's the mu that I'm comparing to. You know, I'm saying that my mu is bigger than their mu naught. This is mu naught, 124. Okay, great. So who said that they would, who was going to share this one? I can't remember now.
It was me.
Okay, great. So are you ready to go ahead and put on your camera and show us? So you guys, listen up. Sarah's going to show us how to do this one.
Okay, so for part number 1, the claim is mu is less than 124. And then the H naught is equals to 124, and H1 is less than 124. Yep. And then for number 2, I found,
I was noticing, guys, you should put mu. Mu is less than, mu is equal to. So don't forget that. Great. Keep going.
And then I found the degrees of freedom, which is n minus 1, and I got 18. And then I got the alpha, which is 0.01, and then the critical value is 2.552.
Perfect.
And I drew the picture there. And then since it was a mean, I used the t-score. And then I got negative 2.91, and then here's
so
the little graph thing.
The only thing is it's negative, right? So then your critical value should be negative. It's less than. So it means that your critical value should be negative, which means that you need to, it should be negative 2.552. You'll still get the same result, because negative 2.91 is still more to the left of 2.552, but that's just one thing. Sorry. Good? Otherwise it's good. That looks great. Keep going.
And then you do reject H naught, and then you reject H naught because there's enough evidence to support the claim.
Right, and then you have to see what the claim is. So I know you guys are like, do I have to write down the claim? Yes, because that's what gives it meaning. The claim that blah, blah, blah. And just write it down verbatim. It's fine. Good. So that was,
claim is H1 is less than 124.
The mean is less. The mean of who? The mean of... the IQ. The IQ, statistics professors have an IQ of less than 124. Perfect. Good. Okay. You guys have any questions? Is that everybody got? So, okay. Great. Let's go ahead and I'm going to take over the screen again and hop into problem, quiz problem. And also, this is kind of what I did. If you guys want to take a look at it, this is what we did in the last class. So this was kind of my result from it. I'll make it a little bit larger. Those are the basic parts of it. Whoops. Basic parts of it there. That's the claim, just like she had. And then critical value, so it should be over here. And then your test stat is in this rejection region. So that's why there's enough evidence. Because you rejected H0, there's enough evidence. It's really important that you guys pay attention to the fact that if you're here, it's guilty. You have enough evidence. And this enough evidence is critical, because if you don't have enough evidence, that's a much weaker argument. And then let me talk, I'll talk about this part, then I want to talk about both those. So H1 is my claim, so I'm going to use the word support there, because rejecting H0, right here I've said that it's not over here, it's over there. So that totally supports my claim. The fact that we got something way over here totally supports my claim. Let me just talk to you guys for a second here. Make sure you guys can all see me. All right, so this is important. The idea that your claim, you're saying that you have enough evidence to support your claim, which means that your claim is totally true. I have totally enough evidence to support it. That's not the same as saying I don't have enough evidence to reject it, because not enough evidence to reject it could be, well, it's wishy-washy, right? Not enough evidence doesn't really, it's not conclusive. It's not very firm. I don't have enough evidence. It may be true, it may not be true. I don't know, I don't have enough evidence. But if you have enough evidence, then you can say for sure, yes, we support the claim because I have evidence, it's strong. Not enough evidence to reject it is like weak. It could be or could not be. So those are not the same thing. Make sure that you're really clear. When you reject H0, that means you have enough evidence. And so it's really an important thing. And then we'll take a look at quiz problem number 2, whoops, which was this guy right here. And again, is this one a mean or is it a proportion? What do you guys think? Mean or proportion? Proportion. Yep. Right, because the word mean is not here anywhere. Mean or average isn't, you don't see it. And then also you have a percentage, and you have a fraction, 42 out of 100. So that's going to be your p-hat, because that's randomly selected. So randomly selected, that's your sample, 42 out of 200. And please note, I'm always going to give you either the percentage or the number of successes. Is this the number of yeses, or is this a percentage? And take a look. So is 42 the number of people, or is 42 the percent of people? Which one is it? Is it the number of people who are obese, or is it the percent of people? Random selected. And, yeah, 42 of them were. So this is the number. So it means that your p-hat is going to end up being 42 over 200. Sometimes I'll give you the percentage, so that could happen. Just make sure you pay attention. Don't always grab the percentage and throw it, whatever that number is, and throw it over 200. Because if this is 42%, then you're done. It's 42%. All right. So who was Sterling? Were you gonna do this one? So Sterling, I'm going to stop share and let you go ahead and explain it. Go ahead.
Okay, great. Hopefully you guys can see okay. Try and hold it as steady as I can.
Oh, that's good. That's good right there.
Yeah. So let's see. Well, P is equal to 0.17. That's the proportion of the population.
Right.
And like Professor Young said, we find the proportion of our sample with 42 divided by 200. So that's 0.21. That's p-hat. Now, it says to reassert your claims based on information obtained, etc. 17% of young people aged 2 to 19 are obese. So that's our claim. Our claim is H0, which is that P is equal to 0.17. And then she just wants to see if that's true. She's not saying anything more or less. So the H1 is that P is not equal to 0.17. So that's two-tailed test, so you can kind of see the drawing here, both sides. And you're going to find the critical value with a Z on the Z table. Alpha equals 0.10, and I got 1.645 for the critical value. That's just all the way on the bottom on the Z table. And then,
do you guys see how he has negative and positive both? That's great.
yeah, two-tailed test because it's equal to and not equal to for our claim. All right. And then for our test statistic, it's just the sample population or the sample proportion minus the population proportion divided by the square root of, you can see right there, the square root of P times Q over N. N is 200, that's our sample size. Then we get test statistic is equal to, I got 1.506. And so if you kind of look up here, if you look on your own papers, it says, if claim is equal to H naught, then use reject claim. If claim is equal to H1, then support. So our claim was that the proportion of our sample was 0.17. So our claim was H naught. Now, since we didn't get in a critical value, now Professor Young may disagree, but I said there's not enough evidence to reject claim that 17% of people 2 to 19 in our sample are obese, but you may very well want it to be something more like.
No, I think that was great. That's perfect.
That's good enough.
Yeah.
Okay.
Wait, did you say you said not enough evidence, right?
I said not enough evidence
Right.
to reject.
Right.
To reject claim.
That's perfect.
That 17% of our sample is obese.
Perfect. And can you hold up your picture again? I want to hold up your picture. I'm going to say something. Right. So if you guys look at this picture, you'll see that 1.51 would be in that white area, which is the non-rejection area. And if it's in there, then that means it could well be that that 17% is the population. So it's really hard to tell since it's in that region. So there's not enough evidence to reject it. It could be that. Thanks. That's good. All right. So I'm gonna jump back in and share my screen. Perfect. I will go ahead. Where is my? Oh, here it is. And I'll show you my drawing. The one thing I want though is don't forget to put the 1.51 in your drawing so I can see, because that way you can explain why your answer is the way it is. So see how it's right in here. So that means that if I'm anywhere in here, then I'm going to say, well, H naught could be true because I expect to get right here. If I'm right here, then I could be anywhere along this range reasonably. If I'm way out here or way out here, then there's no way that my mean is here. And that's when I would reject H naught. But since I got something in here, well, I can't reject H naught. H naught might not be true, but I can't reject it. So I don't have enough evidence to reject the claim that I'm right here, that the proportion is right here. Okay, good. Thank you for that. So now we're going to jump to our 8B handout. So go to your 8B handout, which if you can see my window looks like this, 8B notes. And we're going to go to the fourth page, which is page 16. So it looks kind of like that. Right, so page 16, the fourth page of your 8B handout. And we're going to proceed there. We're not going to write anything down for the first few minutes. We're just going to kind of go over some things. Angela, go ahead and read the first thing for us.
P-value
p-value. The p-value that is the probability of getting a test statistic at least that extreme. The null hypothesis is rejected if the p-value is smaller than alpha. In other words, if the probability of getting a sample like yours is unlikely.
Right. Thank you. So again, the p-value is the probability of getting your sample. So if the probability of getting your sample is small, then that means that most likely your mean is not where you thought it was, right? So, oops, I didn't mean to do that. So, again, going back to what we had here, if your probability is small, as the likelihood of getting something like that is really unlikely, that means your mean is probably not here. Your mean is probably somewhere more closer to that side. And that's what we're doing. So the p-value is the probability of getting your sample. So if you think back to, do you guys remember when I did let me stop sharing for a second. So do you guys remember, if you guys think back when I did the deck of cards? So you had a deck of cards, and we assumed that my deck was 50% red. That was our H0. You were saying my deck is 50% red cards. And then we drew 6 red cards in a row. And if my deck is really 50% red cards, then getting 6 red cards in a row is really unusual. If it's unusual, then we would say that, wait, we got an unusual result. Your deck is probably not 50% red cards. And we would reject the H0 and say that your proportion of red cards is probably something larger than that, because I got 6 in a row, and that's unusual, right? So that's the whole idea. If assuming that your H0 is true, 50% red cards, I get something unusual, red, 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 then I'm going to reject the null hypothesis and say that my deck does not have 50% red cards. Something different than that, something larger. So that's the whole concept. The proportion of getting your H0, your proportion, if that leads to a really low p-value, in other words, a probability that's unusual, like red, 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 red is unusual, then you reject the null hypothesis. So just to kind of talk a little bit about that p-value. The p-value is a probability. Probability is the same thing as area under the curve, right? So it's the area in the tail of your test stat. So if it's on the left side, if it's left tailed, it'd be the area to the left of the test stat. If it's right tailed, it'd be the area to the right of the test stat. If it's two-tailed, it'd be double the area in the tail, whatever tail you're on. I'm not going to spend a whole lot of time on this, just a little bit today. We don't have, there's some things I should cut, and this is one of the things I can kind of cut. But p-values are important because they do come up. They're the way that most people evaluate a lot of hypothesis tests that you'll encounter in the future. So we do need at least to touch on it so you're familiar with it when you encounter that. So this is going to be the first thing on your notes on the top of the page 4. Discuss with your partner how you might fill in these blanks. So I'm going to break you out into rooms in 10 seconds. So right now, take 10 seconds and figure out how to fill out these blanks at the top of the page. Okay, so I'm going to pop you into rooms, talk about it for like 30 seconds, and then jump right back. I'm going to so hop into your rooms and talk about it quickly and come back. Hop in your room, chat, come back. Janessa, Eduardo, get in there quickly. Austin.
My room disappeared. Austin came up and then disappeared. You can do it one more time for me.
Not sure if I can do that. Shoot. Oh, you three just talk right now. Go ahead. The 4 of you, just chat real quick. What'd you get?
The tail. Or the tails first.
fill in those two blanks? Yeah, Ellie's getting back in like 4 seconds.
Okay.
All right, so everybody should be back. So someone give me the answer to the first one. What's this first blank? The what?
P-value.
P-value, great. The P-value. P-value is the what in the tail?
Last area.
Area. P-value is the area in the tail. Yep, exactly, for test stat. Okay, so the p-value is the area of the tail for the test stat. And again, remember, we're going to reject the null hypothesis if the p-value is less than alpha. What's our guideline for unusual typically? Unusual is if it is 5%.
5% or less.
Yep, 5% or less, perfect. So usually our alpha is 5%. But alpha can change. It can be 10% or 1%. So unusual is alpha or less. Does that make sense? So I'm unusual if I'm alpha or less. So here, if p-value is less than alpha, is alpha or less, then it's unusual. Is it, you guys with me? So p-value is my sample's probability. If my sample's probability is alpha or less, it's unusual. If it's unusual, we reject the null hypothesis. All right, so we're going to have you guys, we're going to talk a little bit, let me give you some pictures here first. So again, just to kind of talk, show you guys, so you guys can see visually what we're talking about. Here's my critical value, right? That's my, kind of my cutoff for unusual. And here's the rejection region, the guilty region. Here's the non-guilty region. If you're beyond this critical value, then you're going to be unusual. Here's my test stat, it's unusual. Why is it? Because if we look at the p-value, the probability of this, its p-value is this little area here. And that is definitely less than 5%. This red area here, this whole part here is 5%. This is less than that. It's unusual because this is the probability. So critical value has a probability of 5%. The test stat will have a probability of whatever the p-value is. And if it's less than 5%, it's going to be unusual and he would be guilty. Over here, you'll see, again, here's my critical value, my cutoff, and here's my alpha, which is 5% over here. This area over here is 5%. If you look at the test stat, the area of the test stat is more than 5%. It's kind of larger area over here. So it's not unusual. And you can totally see that, yeah, the test stat over here would not be unusual, right? It'd be in the fail to reject area. Not enough evidence. And then we have two-tailed test, which is a little more complicated because we have alpha in the left and the right tail. So my alpha split half is over here and half is on the other side. So I'm just looking at this part here. This is 0.32%, sorry, 3.2%. So we think that that would be unusual, but the thing about it is it's not fair to compare this amount to all of alpha because alpha split in half. You should only be comparing it to half of alpha in a sense. So if I want to compare this to alpha, since I should be comparing this to half of alpha, then alpha should compare to double whatever this is. So I should double this and kind of make an imaginary one on this side to kind of go with it if I want to do that. And again, we're not going to emphasize the p-value. You don't need to know it at all. It's only going to come up in extra credit on your exam. But I did want you to at least get exposed to it because you will encounter those later on as you get into hypotheses tests. Just for beginning level, I didn't really want to bring it up that much now. So right now, in the next 15 seconds, I want you to take a look. Here, my alpha is 10%. So 10% or less is unusual. My question is, here's some p-values. Are these unusual and will I reject H0 or not? So do A right now, and I'm going to call on somebody randomly in 15 seconds. So do A. 15 seconds. Eduardo, what'd you get? Eduardo? Oh, is he in the chat? I can't get my chat. Did he chat something, guys?
Yeah, I was like it. No, I don't think
Eduardo?
He said that he was still
What was that?
taking the chat. I think he said in the chat that he didn't get it.
Oh, okay. All right, so Eduardo, let me ask you this. This is my alpha, right? 10%. My p-value is 0.107. So is this is my guideline for unusual. Is this unusual or not unusual? Tell me that. Unusual or not unusual? I can't read the chat. I can't see the chat. Someone tell me what he says.
No reply yet.
Okay. So again, this is my alpha. This is my level of unusualness, right? Usually it's 5%. Now I'm saying it's 10%. Is this unusual or not? So,
I would say it's unusual.
Yeah.
well, our guideline for unusual is, what's our typical guideline for unusual usually? What's our alpha usually? 5%? So typically something is unusual if it's what, guys? Unusual if it is
If it's less than 5?
5% or less, exactly. So 5% or less is unusual, because usually my alpha is 5%. Here my alpha is 10%. So unusual will be what?
It will be 10%.
Yes, 10% or less. 10% or less is unusual. If its probability is 10% or less, it's unusual. What's this one's probability? What's
More, and then it's usual.
Yes, it's 10.7%. Do you guys understand this?
Mm-hmm.
So this is more than alpha. So it's not 10% or less, it's more. So is it
I see
unusual?
what you're saying, okay.
Does everyone understand what I'm saying?
It's not unusual.
It's not unusual because it's not 10% or less. Is everybody with me on this part? So this is not 10% or less. So not unusual. Usual. So if it's not unusual, do I reject H naught or do I not reject H naught? It's not unusual. Yep. Do not reject H naught. It's not unusual. Remember, we reject H naught when we get something unusual. Right? Because if it's unusual, remember, go back to my deck of cards. We got 6 red cards in a row. There's no way that my deck had 50% red cards. We got 6 in a row. Well, it's possible, but it's really unlikely that my deck had 50% red cards because you got something unusual. If you get something unusual, then you say, oh, you're wrong. Reject H naught. If it's not unusual, then you don't reject H naught. All right, so you guys take 30 seconds and do B and C. I'll pop you into your rooms. Good deal. All right, so let me ask you guys this question then. Hypothesis test, this one here, results in a p-value of 0.043. So, Rosie, is this one unusual or not unusual?
It is unusual, so you would reject it.
Yep. Reject H naught. Great. And the last one, Adam, what did you get for the last one?
Last one was not unusual, so you do not reject it.
Yep. Not unusual. Unusual. Do not reject H naught.
Quick question, Professor.
Yeah.
A side question. If your calculator has no batteries, where can you get batteries for that?
Oh.
Just trying to say, the one that you gave me, trying to say it's dying.
Are you in Pleasanton? I can leave some in my front door if you want. I've got plenty.
I'm in Livermore, but yeah, I can go out Pleasanton.
Okay.
No problem.
So I'll leave a packet of batteries on my front door, like outside my front door next to the white box, and just stop by anytime, and they'll be there.
Okay.
Okay, just remember, you guys remember, getting to my house, you turn right to get into my complex, and then left once you get in. So it's a right, then a left. Okay.
Okay. No, thank you.
Good deal. Oh yeah, no worries. All right, so you might have noticed, I don't know if you guys noticed, but it's a little bit confusing like the last problem. If you looked at the actual problem itself, it was about the proportion of male golfers is less than 0.7. So then we have a decimal here, we have a proportion here, and then we have this other decimal here, and this other decimal there. There's a lot of decimals going on. It gets a little bit confusing, right, because we're comparing all these percentages, and kind of in a sense you're comparing these probabilities in a sense. So don't confuse the p-value with the proportion p, which is why I kind of shy away from it a little bit, being a wimp, but just really either make sure, like maybe use percentages for this one, right? Use the percent sign and only switch it to decimal when you put it into the calculator, or I don't know, or just really keep track of which one's which and keep that really clear in your mind, because it does get confusing having both of these. But like I said, I'm not going to require you to know p-values or use p-values this class. It might be an extra credit problem, but it will not come up on the exams. So in light of that, since we have kind of limited time, we are going to delete. We're not going to do these parts. I'm not even going to talk about this part, but do circle this bottom part. To find the p-value, we're just going to use stat test and then your test. So it's on your handout. There's two statements. Just kind of put a line through that middle part and underline that bottom part down here. So I'll show you what I'm talking about. So if you kind of take a look right in here at the bottom, down here, just put a line through this part here and circle this the bottom line there. Same thing here, line through the middle one and circle that bottom line there. That's the part that we care about. Okay. And then, lab problem 2, we're going to skip that. So just put a line through it or write skip through that one. We're going to skip that one. So lab problem 2 on the very next page, page 17, we're skipping. All right, so then we're going to take a look and continue on. I'm going to talk about how to use a TI-8384. This is going to be, all right, let me go ahead and stop.